Hi, this is Sonia Doucette. In this video, I'll show you how to calculate the theoretical yield. The problem says if 80 grams of water react with 65 grams of lithium oxide, what is the theoretical yield in grams of lithium hydroxide? So the reaction is shown here. The first step in finding the theoretical yield is figuring out which of the reactants is the limiting reactant, because that is what you're going to use to determine the theoretical yield. So I'm not going to go through the whole process of determining limiting reactant again because I already did that in a previous video. But let's just say we're going to figure out what the limiting reactant is. And let's say we want to figure out how many grams of lithium oxide are needed to react with all of the given amount of water. So we're given 80.0 grams of water, and you want to get from grams of water to moles of water to relate the two reactants to each other. You always have to relate things through moles. So the molar mass of water is 32.256 grams of water for 1 mole of water. And now you can look at the stoichiometry and see that for every mole of water that reacts, 1 mole of lithium oxide reacts. So you have 1 mole of water for every 1 mole of lithium oxide. And there should be a subscript 2 there. Okay, and then you want to get to grams because you want to compare how many grams of lithium oxide are needed to react with the 80 grams of water and compare that number to how much lithium oxide you actually have, which is 65 grams. So you need to get to grams of lithium oxide. So all you do is use the molar mass of lithium oxide, which is 29.88 grams of lithium oxide per mole of lithium oxide. So all your units will cancel here except grams of lithium oxide. Those are the units you're left with. You do the math, you get 74.1 grams of lithium oxide being needed to react with the given 80.0 grams of water. Now you only have 65 grams of lithium oxide to work with, so that information tells you that lithium oxide is limiting. So once you know what the limiting reactant is, you want to use the starting quantity for the limiting reactant to find the theoretical yield of the product. So the product in this case is lithium hydroxide. So we're going to use 65 grams of the lithium oxide, which is what we're given because lithium oxide is the limiting reactant, to figure out the theoretical yield of lithium hydroxide in grams. So we're going to have to relate those two through moles using the reaction stoichiometry. So let's start with what we know. You know that you have 65.0 grams of lithium oxide to work with because that's your limiting reactant, and you want to relate the two through moles. So you use 29.88 grams of lithium oxide per 1 mole of lithium oxide for your molar mass of lithium oxide. And then you know by looking at the reaction stoichiometry that you have, for every 1 mole of lithium oxide that reacts, 2 moles of lithium hydroxide are produced. So you can see this in the reaction stoichiometry by looking at the balanced chemical equation. You have 1 implied 1 mole of lithium oxide. For every 1 that reacts, you get 2 moles of lithium hydroxide produced as your product. So the next thing you want to do is get to grams of lithium hydroxide. So you just figure out the molar mass of lithium hydroxide, which is 23.948 grams of lithium hydroxide per 1 mole of lithium hydroxide. And everything cancels out here except the units that you want, which are grams of lithium hydroxide, and you do the math, you'll get 104 grams of lithium hydroxide. So that is your answer. That is the theoretical yield based on the quantity given for the limiting reactant.